Okay, so you definitely need to work hard. If you have not done MLP, see those who have done MLP, you would have already gotten some good experience with coding, including NumPy, Pandas, Matplotlib, and of course sklearn. But those who have not done MLP, you need, yeah,
Mom, it's in parallel, like MLP and the DL course.
yeah, no problem. You'll do it there also. In Pandas, Pandas will be done in MLP in the first week, right? So
So
the
that
three
will do
weeks,
no, ma'am. The first week, first 3 weeks will do no. For the
first 3 weeks
basics
of what?
of MLP will suffice this prerequisite of pandas, numpy, and
Yes, yes. If you can do that, fine. Otherwise, in week zero of this course, we have added some links to NumPy, Pandas, Matplotlib resources. So, would request everyone to go through that. So, you definitely would need to put in extra effort to understand that, because that all that is kind of prerequisite for the week one of this course. Because we are starting off with PyTorch introduction in week one of this course, right? Given the kind of content that this course has, um, there's too much breadth. We're covering we are going to cover a lot of things in this course, so all of you would have to really work hard, do your own exploration as well. We'll try to cover as much as possible within these 12 weeks, right? But like I said, those who have not done MLP are coming from Python, right? Python and MLT is what you would have done. That is the only thing that would be relevant for this course. So you will need to really do good practice on Pandas, because Pandas is going to be required for pre-processing the data. Before you do anything in PyTorch, build models, you would need to do a lot of pre-processing on the data. For that, you have to be good with Pandas. NumPy will be used here and there. NumPy is very close to PyTorch anyway, so a good understanding of NumPy would also be needed. And here and there, you would have to plot things. So Matplotlib, Seaborn would be required. All these have been added in week zero. Some resources have been added, but you're suggested to go through these resources wherever you can, wherever you want. Okay, that's week zero. That's before you start of week one content. Okay, yeah, that's one point that I had to make. Um, Throw some light on project. Okay, Rahul. For project, there'll be separate session. You'll be informed. I think this weekend we'll have a session to introduce you about the specifics of the project. So you can stay on hold there. Yeah, I think, yeah, Puneet, you can get started.
Yeah. Okay. Thank you, ma'am.
Ma'am, just one more question before Sir takes over. I was just referring to the week 1 and 2 G Drive folder which Levin Sir had shared with us. So, in that, ma'am, first of all, I would like to thank the instructors and you because the notes are quite comprehensive and they are quite good. And, ma'am, one more thing, the PPT that has been shared is that the
Sorry,
combined
Aditya, I
PDF.
missed you. What did you mention first thing?
Okay, ma'am, firstly, I was saying that I would like to express my thanks because the notes that you have shared, the instructors, they are quite comprehensive and
For
they'll be
week one,
very
you mean,
helpful.
or which one?
Sorry, ma'am?
For week one, you mean?
Yes, ma'am, the two collab
Okay.
notebooks that have been shared.
Oh, okay, okay.
Okay. And ma'am, secondly, my question was that there is only one PDF in that. So is that the combined PDF for both the weeks? The PPT.
Is it? Let me check and confirm that.
And
Okay.
there are
I'll
no
have to
notes.
check
Just
that.
the just
So, mom, which notes?
Which note you are talking about? Like,
Oh, Levin sir has shared the link on discourse.
yeah, that is just for week one, I guess, not for week two.
is there any discourse for this course?
Yes, yes.
first thing, the lecture notes are that is only available for week one right now. It is just saying it is week one and two. It is mainly for week one.
Okay, sir. Okay, got it.
And discourse, yes, it is there. Some people might not be added to that. They will get added later. Yeah. Any other doubts?
Sir, please do share these notes on
We
this
will have
page,
the NPP
course
into
page, if
NPP.
possible.
One by one, please. Aviran.
Yes, sir. I just request you, like, if possible, you can share in the course page those notes if possible, because we don't know about the discourse link and we don't have any idea. So,
Okay, okay, okay. So this,
extra content.
yeah, this Ashish Raj has given this. Yeah,
Sir, this is now also available on the course page under the
yeah, yeah.
supplementary
It
content
is
section.
available, so you guys should be able to access this. Okay. Uh, any other? Shivans, you were saying something?
So yeah, I was asking that in the grading document it's mentioned that we will have two non-proctored programming exam, that is NPP. So what is the
Hmm.
NPP? Like I went through the grading document, I went through the course,
Yeah, it is
the
just
course,
the
but
OPP. The only thing that you
yeah,
don't have to sit in front of a proctor. It is non-proctored
yeah, but
programming exam.
what OPP? Like we will have which the Python OPP? Like what? How will it work?
So,
That
as
was my
ma'am
question.
mentioned, na, this course is about PyTorch mainly. So,
Yeah,
obviously, the
exactly.
questions will be revolving around PyTorch. That whatever you have studied, that only will be asked.
Okay, so okay, thank you, sir. And one more thing, sir, like so like I was not allowed to take the project in this term because I think the limit was not, like 200 only, so I was not allowed. So in this term, will I not even get access to the project courses, or like will there be separate courses for the project? And like if I am not getting chance this term, how can I be assured that in January term I'll get the chance only? Is
This
there some
is
criteria?
more of a operational thing. I can't say much about on this
In
topic.
January term, it will be open for all, so you can take enroll in that. It will be open for all, no problem.
Oh, okay, thanks, sir.
Okay. Uh,
Thanks a lot.
yeah. So, okay, I'll start with week one now. So, I'll get back to pandas also today. So, what you guys like? So, you see, you guys have studied a little bit about machine learning foundations. In that, you have studied regression, classification. You have seen little bit about programming also, and some parts of maths like what so far I have seen. Some parts of things like linear algebra will also be like involved. Um, Now, essential libraries that we will be following now and then. First thing is obviously PyTorch. In that you will also learn about tensors. So now, what is tensors? Tensors, you will see, is just another kind of a data structure. In very vague terms, it is a data structure, and we'll be using tensors. So it is commonly referred tensor is commonly referred to as a deep learning language. As Sir also mentions. So we'll use the Google Colab itself to start with. So why we are doing like deep learning? First of all, so like machine learning, if you have done, some of you have done MLP project, or you would have seen an MLT as well. There are hyperparameters. You have to manually do the feature engineering, right? So the first difference here is that the deep learning will allow you to learn the features automatically. Then machine learning has some restrictions till where it is able to learn the patterns present inside the dataset. So it is generally said that it learns the shallow patterns, whereas deep learning allows you to build a huge neural network, and you can like slowly build over the hierarchical features as well. Okay. And obviously when there is a data scale thing coming, then also deep learning has a proven edge over machine learning. Okay, so this is a very vague introduction for you, why deep learning is being introduced. Slowly you will learn a little bit about, if today time permits, we'll see this maculopix neuron and how it came to perceptron and so on, other things which is present in week one itself. First of all, I will start with a little bit an introduction to pandas. So I'll just share my collab notebook. Will do, and I would request that you guys also open your Google Colab with you, and so that you can also practice little bit. And if you have doubts, you can ask me here itself. Okay. So,
Sir, is the recording started?
yeah, yeah, recording I am doing on local device only. Yeah, yeah, it's
Okay.
being done. Yes, yes. Okay. Uh, yeah. Okay. So I think so. My screen is visible. Just a minute. Yeah. Um. Okay. So first of all is the obviously the import statement. Import pandas as PD. So most of you, like if you are doing in your Google Colab, you don't have to install the pandas. But if you are doing it on your VS Code or some other thing, then you have to do pip install pandas, and then you can use the statement import pandas as part. Okay. Yeah. So now it is done. So what is basically pandas library? It is mainly mainly it is an it is an effective tool where you can work with data sets, right? You would have seen like getting a CSV, performing some operations, removing some columns, do some data analysis on that. So this is where the pandas actually excel. Okay. So it has numerous functions for analyzing, cleaning, exploring, and changing the data. So the main concept is that data frame. It uses the concept of data frame, and within that, it will do everything. Okay. So yeah. So let's start then. We'll start with the Pandas series. Because this is related to, because you'll see in Tensor also there is this series kind of thing where you will see how you can create a scalar, vector, and matrices. Okay, so let's start with Pandas series. We have imported it. I'll define a list. I hope you guys know what is a list. So I've defined a list, and I'll say some variable var is equal to. Now I have to convert this. Now it is showing me this already that I want to convert this list into a series. So what I'll do, I'll call pandas. On pandas there is this function series. Inside series, I'll pass this list that I've created as a parameter. Okay, and then we'll see how it works. See, it has now converted this into a data frame. You see 012, now it has become a data frame. If you want, you can see print type of var. Yeah, see pandas core series dot series. So series is a class. Within that, it is saying that this is a series. Okay. If you want, you as you used to like access the values, you can again access the values from in here. Let's say I want to see the first value, so it says 7. And obviously if you want to change it, you say 2. At the third position, which is for we know 0 1 2, second position we have var 2. Okay.
So what's the difference between series and that 172A?
This now, so
Yes,
this
yes.
is just a list. This is a Python list, right?
Okay.
Yeah, Python list. Now the thing is, what we are trying is, we are trying to either build, the goal is to build a data frame. A data frame is like two dimension, right? It is x and y. It's big data set you would have seen when you call something, right? When you say read underscore csv, you call some csv file, then you see some rows are there, some columns are there. Right now I have nothing. I've made a series. You can see that these are indices 0 1 and 2. Is it clear?
Sir,
Like so for the list we cannot access it through like A1, A of 1 or
No,
A
no,
of 2,
these
but
things
for
are available in these. See, this is not a huge difference between list and series. What we are doing in,
okay,
we are slowly moving towards that.
okay,
And
okay,
list also, you can say list of 0 is, you will get that index. That is not a big deal. We'll slowly come to that. You will see why this is very helpful.
okay, okay, sir.
sir, series is 1D and data frame is 2D, right?
Yes, you can say kind of. Yes.
And we are using series, so it will be efficient. That space. This is the reason, or is there any other reason?
Think of this also a reason. More reasons will be clear to you once you reach there, I would say.
Okay, sir.
Okay. Yeah. Okay. Now let's see one new thing here. We saw how you converted a list into a series. Okay. Now, what if you wanted to change this index name itself? Okay. So what you have to do, I'll say var1 is equal to pd.series again. I'll okay. So this is capital.
Good evening, sir. Hello.
Yeah. Yeah.
Sir, what are we discussing today?
Okay.
Sorry, we just joined now.
Because most of you guys, this is week zero part only, pandas. So I'll just touch few things on pandas, and
Okay.
then I'll move to the main week one, some introduction to PyTorch. That is the main goal. We'll try to finish as much as possible. Not everything, but at least the introductory part, what is present in PyTorch, we'll try to cover that today.
Okay. So right now, week zero.
Right now, I'm doing
Yeah.
some pandas. Yes, yes. Just to show
Okay.
you how it is being done. That's all. Okay.
Okay. Thank you.
Yeah. Now let's see. I run this. Now you see the difference using the same list that I had created earlier. A is equal to 1, comma 7, comma 2. I have created another series. Now this time my index is what I wanted it to be, right? So, do you think this can could have been done using a dictionary also, right? If you remember how this dictionary is written, let's say I'll say y is equal to, just make two or three, not more than that, one, y, yeah, okay, this is c 7, yeah, and then we have z 2. Okay. Now if I say where 2, where 2 read is y print, yeah, you see both are same, right? Now you can see how a dictionary and a list, both of them could easily fit into our series model that we are using for data frame, right? What is this? It is only single dimensional, right? We don't yet have a data frame, right? So now we'll slowly go into this 2D world, okay, where we have
Okay,
multiple,
sir.
yeah,
Excuse me, sir. Sir, in var one, the series that you created over there,
yeah,
if we just try to use the regular method of accessing the elements,
yeah.
for example, if we do var one square brackets 0 or 1 or 2, it would throw an error, right?
uh,
But if we use iloc, then only then we'll be able to access it via the indices.
yes, yes, yes.
Like if we do var one and 2, like now, so then it will throw an error, right?
Where, no, see, we have three wheres now. There is one
Sir,
where.
var one, I'm talking about the one in which you have given the index as
Yeah.
XYZ.
What you are saying, if I say where one, what, second
1,
position,
sir, any numerical index. Yes, sir.
yeah, then
Print where one of
it will
two.
give you an error. Yes.
Yes, sir.
So why you are specifying the index to be XYZ? I mean,
No,
normally we have
just
the
explaining few things. There is no
okay.
such reason. Just showing
Okay,
you
sir,
how
this
powerful
is what I
pandas is.
was talking about. Excuse me, sir.
Yeah, yeah, please tell.
Sir, so the result you got was a result of the version you have, right? Of the pandas version. Uh, right now, because of the discrepancy in the versions, what I am facing is that in this collab version, we are still able to access it via 0, 1, and 2, even if we give a specific index. But then it says that in future versions, these indexes, if we are not using iloc, then it will only be referred to as a label. So, sir, let's say we get this question in an exam
No, no,
or
no. First
somewhere.
of all, to be clear, pandas you won't be asked. you have a lot much more information in PyTorch that is presently left to be learned, that will come in exam. So
No,
also
but
it
sir,
is
it's
not
basic, right? We need it to
yeah.
understand what comes after.
Okay, so maybe see most of the things that I have seen, like in exam, it will be specifically mentioned which pandas version is being used, and on the basis of
Okay,
that
sir.
only evaluations are done.
Okay, sir, great.
Yeah. So maybe mine might be the older one, yours might be the newer one, but those
Yes, sir,
things
there is a
will get
discrepancy.
yeah, those things will get resolved during the exam.
Okay, sir.
So during the exam, there is a fixed thing you have to use that, and you everyone
Okay,
will
sir.
be evaluated on the basis of that only.
Okay,
Okay.
sir. Thank you.
Okay. Now let's from series world we move to the data frame. Okay. So which is the actually the most good part of pandas that I have seen so far. Okay. So we'll start with some variable uh, three now. Okay. Now I define a variable. Uh, I am getting something, so I'll take this only. And since now we are not making a series, okay, so that is it.
So just want to ask one thing, little thing. So we have ilog and we have log, right?
Hmm.
So you are using XYZ as index, right? So XYZ we can access by log, right? And for if I want to use 0, 1, 2 indexing, then I can use ilog, right? Even if XYZ are the indexes.
iLog will allow you to do numerical indices, right?
Okay, so I can use where to dot ilog ilog 0. So the answer will be 1, right?
It should be. You can try
Uh,
once.
okay, sir. Thank you, sir.
Yeah. Duration 2, 4, and 6. And yeah, pt dot. Okay, this is a data frame. I want this to be a data frame as well. Yeah. So now what you see is this is a kind of a CSV table, right? From here only you move to a CSV, right? So you can easily convert this into a CSV table. Now what I have done, I have created two headers, calories and duration. Okay. Now I say that 100, 200, some I have given some random values, and duration is for how many days I've been working out, something like that. So this creates a data frame. So this is, you can think of this as a two-dimensional data structure. It is like a two-dimensional array, 2D array, and we have rows and columns. So what are the columns? I have calories and duration. Remember that during when I convert this into a CSV, there is an automatic method. If you want, if you put index is equal to false, you will not see 0, 1, and 2 in that CSV. But if you want to see those in index also, then index is equal to 2. I think so. That is the parameter that you have to change. Okay. So this thing is not by default. This is what Pandas has given to us to make some easy decisions. This is not the official index. If you want, you can add your own serial number on top of it, and that might be your index if you want to keep. But this is given by Pandas, and while conversion, there is a thing called index. You have to specify true or false when you are converting it into a CSV file. Okay. So now this is what is we have a frame. Okay. Now let's say now if you want to uh, find some particular row. Okay. So what you will do? So I will say print df dot log square brackets 0. Okay. What will this give me? This will give me the zeroth row, and it is specified from which particular header it is coming from. So from the zeroth row is calories is 100 and duration is 2. So this is that particular row. Let's say if I change this to 2, I get calories is 300 and duration is 6. Okay. So, and what if you want to know what is this type, you can say actually I can't write this. So print type of df.log 2. Can anybody tell what should be the type of this? I'm not press entered. Any guesses?
Series.
Very good. Why?
Series.
Because those series have combined now to become a data frame. Inside also, inside the data frame also, we have this
Individual row is a series, right,
individual
sir?
rows are series. Very good. Okay. Now, let's say if I want to get two rows. So what I'll do, I have to specify this. Um, use a list of indices. Now this df.log, this first square bracket belongs to df.log. Inside that I'm specifying 0 comma 1 so that I get two rows instead of only single row. Okay. Now this, what should be this data type? What should be type of this?
Data frames.
Yes, very good. So now
Data
we
frame.
again have a data frame. Okay. What will happen if I remove this? It won't even work.
Error. Yeah.
Yeah? Um, okay. So
But we
this
can
is,
do df.log.
yeah, sorry.
We can do df.log 0 in single
Yeah, single
square
is
bracket.
fine. If I'm getting single thing, then it is fine. That time it is a
Okay.
series. But when it is saying 0 comma 1, it won't work. We have to put
Oh,
that in a list if you want multiple rows.
okay, sir.
Okay. Moving ahead. Yeah. So now we have to have, let's say I'll create some CSV file. Okay. Very simple CSV file. I'll create something. Just give me 2 3 minutes. I'm just creating it. Um, X class marks 5 classes 5 6 7 8 9. I'll put some random marks to it. 20. So I'll just save this now. This CSV.
Sir, we are not able to see
Yeah,
anything
yeah.
what you are typing.
I was doing it on my personal computer, just saving. I was trying to save it. Now I'll upload this, then you guys will see. So how now? First of all, we'll try to import this. So we have already imported Pandas. We'll try to bring this CSV file here. So I'll say df is equal to pd dot read underscore
Yes.
CSV. Yes. Practice dot CSV. Okay. And then we'll call the print data. Now you see, this was what I was talking about. That you can create a CSV file. What is CSV? CSV is nothing but a rows and columns thing, right? So now you can do this on a much larger scale. This is a very short thing that you are seeing here. Now you can, from here you can move anywhere actually you want. Okay. Okay. So I think so. This is some basics about Pandas. Those of you who already know, it was just a revision for them. Those who didn't know, I hope so. This would help you to understand what this Pandas is, how to, what is a series, what is a data frame, how you can call uh, this CSV file into Pandas, and you can perform some things on them, at least few things. So if there is any doubt here, you please let me know. Otherwise, now we'll slowly move to PyTorch.
Sir, just a little doubt, sir.
Yeah, yeah.
Sir, I just completed a MLP course. So whatever I have learned, like in MLP course, we used to clean the data and impute the data and all these things we used to do. So those things will be handled by deep learning, or we have to do here also, like.
In the first week itself, you will get this clearly that using the tensors thing, you will get a data loader kind of thing. Okay, so
Okay.
you have this option that you can clean it using pandas, and then obviously while loading the data into your models, now you will be using tensors. So there is a data loader function that you will learn about, and using that only this it will work.
So we don't have to use this grid search CV or different type of machine learning techniques, or like.
Yeah, now you will be writing them by your own on your own. You will have your custom functions. You will learn about this in this week only.
Okay, sir.
Please don't worry.
Okay, sir.
I'll just start with a Tensor's PyTorch introduction, and
Sure.
maybe we'll see where we reach today. Anyone have any doubts so far?
No, sir.
So
Okay.
this is all the basics about
Yeah, very
pandas.
basics. Yes, very basics only. So yeah, and few more things are left in pandas. You guys can look on some, you will get some information on your portal also, and if you go on internet, you have plenty of information. You just have to learn how to like, let's say you have some this class, let's say marks was missing, then what you will do, you will do some imputation, right? So those things you'll learn slowly. Okay, now I'll start with the introduction to PyTorch. Okay, so
Hello, hello, sir.
hmm,
Sir, we can also do deep learning with TensorFlow, right?
yes, you can do.
Sir, then why we in this course why we choose PyTorch? I mean, means any extra features?
So if you see, if you do go through the entire you right now, you guys in diploma, you will see in future also. I have completed this DLP and LLM courses. There, this PyTorch is also being used, so it is standardized across the course. So I think so that might be one of the reasons, but the final reasons I also don't know. It is dependent on professor what he has chosen. So we have to stick with that.
Okay.
Okay.
Yes, sir. Thank you.
Okay. So for now, this torch will PyTorch will be little bit difficult. But yeah, I hope you guys practice it enough so that you guys do well. So with that note, let's start. So first thing is import torch. So now torch has been imported. So if you want to check what is your torch version, so you have to write torch dot underscore underscore version underscore underscore. Okay. It will tell you which version is this. So it says 2.8.0 plus CU126, something like that. I think so. This is
So sir, in Google Colab, Torch is already PyTorch is already
yes,
uh, available.
yes.
Right.
For those, just let me check. If for those who are doing it on your own computer, I think so. You have to, yeah, you have to install pip install torch. You do this and then it will work. Okay. For those who are not doing it on
If
Google.
we are using VS Code, then we
Pip
have to
install
use
torch.
Torch. Okay.
And I would suggest please do it in an environment. Otherwise, it will conflict with your global variables, because torch in itself has multiple dependencies and it is a huge library. It comes with all its advantages.
So if we are using Google Colab, we don't have to
No, you don't
re-upload
have to do anything.
download it.
Yeah,
Okay.
We have to enable GPU, right? GPU.
I'll show you. I'll show you.
GPU.
GPU will come. I hope it comes today. So I'll show you how to enable it. Little bit busy. Everyone gets in collab. You get some at least 14 GB kind of thing, GPU. So you can use that. There is some limitations. 30 hours. Some limitation is there. I don't remember. Weekly you get only 30 hours of GPU, something like that. But
Okay,
This
sir.
is Kaggle. This is Kaggle. On Kaggle, you get 30 hours per week on every GPU. There is T4 available. There is some more available. So you guys can explore more once we reach there. Okay. Now we saw this as the CU 12.6. I think so is CUDA. It says that this torch is works well with CUDA 12.6. I'll show you which CUDA we have in Google Colab. It will come later. Okay. So first of all, let's start. First thing is always in any library. If you're like we saw in Pandas also, we started learning how to get data into the proper format and see which output we are getting. What is the data type we are getting, right? So for that, in Torch we use tensors. Now let's see what these tensors are. Okay, so I'll introduce a variable a. I'll say this is a torch dot tensor, and I'll place some value 7. Okay. Now first of all, I'll print what is this a. Okay. So this says that this is a tensor 7. Now you'll see think that 7 is no, this is only a number 7, but this is the way how we define a scalar in PyTorch using tensors. Okay. Now what is the value within this scalar? Okay. Now what you are seeing right now is tensor 7, right? What I will do now, print a dot item. Okay. Now you get what item you have stored in. So ten, a is a variable wherein you have stored a scalar tensor with value 7. That's what was showing you tensor bracket 7. But when I asked for what is the item within it, it showed that this is 7. Right? Now, what is the data type for this? Now, since I have not mentioned any data type, so right now it will take the default data type, that this is an integer 64. If I would have said this, then when I did 7.0, then the method of writing that in the tensor is 7 point nothing. It does not show 0, and it is float 32. Right now we will stay on this integer 64. Okay, so this
So
is the
if you write
data type.
7.2, it will show tensor 7.2.
Right, but with so many zeros,
Okay.
and the item
Okay.
is very much like it goes till float 32. It literally goes till to float 32. Okay, we'll come to that.
Yeah.
We'll come to that. Yeah. So the data type is so we have to remember this is a common mistake when you will be doing some operations on tensors. No? So tensors data type is very important. You can't actually see, you can't do some operations when the data types are different. You will see this uh, coming time. Okay, so it is very important to make sure what is the d type. Remember earlier you used to do type, now you are doing d type, that is the what is the data type. Okay, now what is the shape of this? Okay, print a dot shape. What is the problem now? Oh, this is not a function. This is sorry. Yeah. So it is saying nothing. Nothing means it is a scalar value. Okay. And we will also call print a dot size. This will also be an empty. Empty means it is in 0 dimensions. Okay. Whenever you see, whenever you get a scalar value, it has 0 dimensions. I'll explain you what the 0 dimension means. I'll say dim time is equal to a dot dim. Okay, and I'll just say print time. Now you see this scalar value does not have any dimensions itself. Since does not have any dimensions, therefore it will not have any shape and it will not have any size as well. That's why it was showing you this empty list. It's not a list actually, but yeah, you can think of it like that. It is empty. Okay, so this is the reason. Now let's try to define a list. We saw how to define a scalar value. Now we will try to define a list. So I'll say b is equal to, and we'll see what it becomes actually. Torch dot tensor, and I'll define 1.0, 2.0, 3.0, and again I'll copy this. Okay, I'll copy this. Um, I'll just say this again, a itself. Okay, there is one problem here. This will not work. This a dot item will not work. Okay, why it will not work? Because now this tensor has three elements. Now the three elements cannot be directly said anything to a scalar. If you do a norm, or like you do a norm of a, then you get a scalar. But otherwise you won't get a scalar, right? Is this concept clear? That's why we cannot say that this has a particular one, only one item, because it does not have a scalar value right now. You have to convert, you have to get a norm of this, and then it will be able to give you this. We'll show how a norm can be calculated. Okay, so for now I'm removing this line. Now you see, now this 1.0, 2.0, 3.0, this is a float 32. What it says, the size is 3. It is in one dimensional only. Now what we can do, we can say print a dot end. Let's see this. It is in one dimension. It is not yet two dimension. So the things like list comes under one dimensional. Okay. So now we have converted it into a tensor. This tensor is 1 point comma 2 point. This is a standard way how it is written. Please don't worry. The things are not different. It is same only. Data type is float 32. Size is three elements in one dimension, and shape and size is same, and it clearly shows a dot end dim shows that this is a one dimensional structure. So yeah, now
Sir,
yeah, yeah.
sir, in this, what is this stars dot tensor trying to do? Is it trying to convert the array into a tensor
Yes,
um,
it is trying to convert this list or array into a tensor object.
tensor object, right?
Yeah, yes,
We can write any single value also. It will convert it to tensor object.
yeah. So what we are
Mm.
right now learning
So,
is we can convert a scalar, we can convert a vector, we can convert a matrix as well into a tensor object. Because while
okay.
when you will start modeling the linear regression or some classification model in Python, you have to send a tensor object, not your general array and those kind of things. That's why you are learning this. Is
Okay.
it clear?
Yes.
Okay.
So one more
Sir,
doubt. Like here you have told that why like so can you tell again that why we are not able to get the value of that a dot item print a dot item why we are
uh,
not getting?
so that error you saw now, I'll show you that error again. It says see, now this is a tensor with three elements. Now my tensor does not only have one element. It is in one dimension, but it has three elements inside. You can't take out a direct scalar value. Even for a list, there is, if you see a list also, 1 comma 2 comma 3, you can't give directly a scalar value to it. Okay, you can say that the max of this list is this, minimum is this, or the norm is this scalar value, but directly there is no scalar value associated with a list. Similarly, when a tensor has three elements, we cannot directly call that. Okay, so there is, therefore this a dot item is not working on this, and a dot item will not work on matrix also. We will go till two or three, we'll go till three dimensions in this course, because zero is scalar, one dimension is this what you are seeing list, two dimension is when you study a matrix, and three dimensions when you study an image, because it has a channel, it has a height, and it has a width. So it has three dimensions. Okay, so this is
So
my
what you said first for image?
sorry,
What you said
channel,
for image?
channel.
Channel.
Yeah.
Okay. And sir, what does this mean by converted to a scalar? Not able to convert it.
Just showing.
And
Next sentence is that one. Just give me a minute. Okay.
Excuse me, sir.
Hmm.
Sir, in the list, if we had a list, we can access the individual components. Like if we have a list as 1, 2, 3, then we can access the 1, 2, 3 by a square bracket 0 or a square bracket 1. Can we do the same in here? Like access the individual components?
Yes, you saw. See how it is being done. And if you put dot item here, it will work. You see, it works. Clear,
Sir,
everyone? Yeah, yeah. Digital.
so initially you have taken a equals to torch dot tensor 7, right? Just a single element with a zero n dimension, right?
Yeah.
Now, if I take 7 comma 9, can I take it or I have to take it in an array form only?
You have to take it in an array, no?
Okay, so if I want to take 7 comma 9, so it has to be array. It
Yes.
cannot be single.
Yes.
Okay, sir.
Now, I was showing you this. Yeah, dot item. Now this dot item will work. Okay. Now, what if you want to take what is the max value? Maybe the sum of these elements. Okay. What you will do? You will say torch dot sum. You pass the entire tensor object A, and then you call this item function. You see 6.0. I hope there is no confusion. I'll just do everything. Yeah. Now you see the sum of these elements. What I did was torch dot sum. Inside this sum, I pass this tensor object A, and then I call this dot item. Now you know
so
why dot item is working here and not working on the entire. Now it is a see
dot
sum is a singular scalar value. Now I can call the item function. We can see
so dot item is taking the single value from the uh, tensor object
yes,
A, right?
yes, and also you can calculate the norm. Print
No.
torch dot norm A dot item.
So without dot item, it will simply print tensor object
Yes,
with the item inside.
yes.
Okay.
See tensor. This is a tensor object.
No. Okay.
I hope you would have studied norm in somewhere MLT, MLF maths. Somewhere you would have studied what is norm.
Yeah.
I think.
Yes.
Okay. Good. Okay. Now I hope this is clear. So you have studied how to create this thing. Hmm, how to create tensor for a
Sir,
scalar
can you
value.
please print the type of one of these statements once?
Yeah, yeah, sure, sure. It is tensor only. Torch. I'll still tell type of torch dot norm a dot item class. Oh, sorry, item is obviously float, but if I remove this item, this is torch dot tensor.
Okay, sir. Got it.
Yeah, when you call that dot item, it becomes a scalar value. Now the scalar value will have its own data type, like it showed you earlier, float, or in the
Okay, sir.
earlier case, it was an integer.
Okay, sir. Thank you.
Okay, now moving ahead, now I will try to show you two-dimensional thing. Okay, let's call this again A only because I'll copy it from above. Torch dot tensor, and now see very carefully. I introduced the first bracket. Then I introduced one more bracket. 1 comma 2 comma 3 comma 4 comma 5 comma 6. Okay. Now, what is the dimension here? Can anybody tell me? What should be the predicted dimension now?
Sir,
Two
2.
dimension.
2 comma 3
2.
comma
3.
3
See,
2
now you guys
2
can.
2
Dimension.
Uh, okay. Now, one more question. This time, A of 0 dot item, will it give me error or will it work correctly?
it will
Sir,
It
it
will
will give
work
an
correctly.
Error.
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 it will be error
Very good. Very
will
good.
give
It will work
errors
correctly.
So now you can see tensor is matrix. First row is 1 comma 2 comma 3. Second row is 4 comma 5 comma 6. With these rules, we know this is a 2 cross 3 matrix. As you can see, torch dot size is 2 comma 3. Shape is also 2 comma 3. And it all the values are integer 64 values. And what is the dimension? N dimension is 2 only. Okay. This is not 2 comma 3 2. This is not that thing. This is how many dimension it is. It is only two dimensional. Matrix has only two things, rows and columns, right? Now what if I wrote this? In this only I'm showing you guys. Okay, what if I wrote this? Now you see,
One
this is one channel, two rows and three yeah, so one channel is there. If this first, oh, this is the outer dimension. Inside that you have this dimension, and within that you have this dimension.
It's basically like we have got three separate
Yeah,
axes, X,
all
Y, and
this
Z.
will be used when you study. I think so. Week 10, 11, and 12 you have is the computer vision part. There, this is a must. I'm not explaining much about this right now. This is a 3D thing. So,
So I didn't get this thing, how you did.
okay.
sorry, sir.
So,
Could you
sir,
please explain why
is
is the dimension three?
I'm coming to
Like,
that.
sir,
like
would
sir,
this be similar
the
to
number of
the
tablets
image
will choose number
classification
of
portion in
dimension.
MLP?
Mm, See, honestly, I did MLP a long time back, like 2 3 years back. Okay, so I don't know what changes are there right now in MLP.
Okay, okay. Sir, like the overlapping of pixels, RGB, and that sort of thing in the three
No, no, those
dimensions.
are very like it is more of a data handling kind of thing. Here you will learn about how to means model these vision transformers. Those
Okay,
kind of
okay,
stuff you will learn. I think so. They are pretty different. I'm not very much sure because I
So,
don't know what the MLP course is nowadays.
okay, sir.
Yeah,
so basically, like the number of dimension depends. Like here, we can easily see if you increase the third bracket, it will dimension will also increase, right?
third bracket. Yeah, if you make it four bracket, then yes, it becomes
Yeah,
4D.
yeah. Okay, fine, understood.
Yeah, it will become 4D. You are correct.
Then
Some.
then the size will be 1, 1, 2, 3 something like that.
Yeah, yeah, one, one, two, and three.
Sir, why you are keeping three brackets, three square brackets?
No, because I want to introduce 3D, how a 3D thing will look like. Let's say inside this, what I'll do now. 1 minute, give me a minute. This is the first matrix. I'll just call something in here. Okay, comma. Okay, inside this, I'll say 1 comma 2, and I'll say 2 comma 4. I don't know whether this will work or not. Let me see. 1 minute. 4 comma 5 comma 6, and let's say no, I can't make 4 5 6 also because it is being used 7 comma 8 comma 9 to show you the difference. And this I'll call 0 comma 1 comma 2. Okay. uh, yeah, blue. You see the color combination also. This is the pink bracket, is the outermost bracket. Now how many channels are there? Two channels are there. Any doubt there, everyone?
No, sir.
No, sir.
There are
Sir,
two
what
channels
channel
now.
are, hello?
Yeah,
Sorry, sir, channel, how you are saying it?
no,
Blue
sorry,
bracket.
it is my mistake. I said it channel. So outermost this dimension will be two, na? Whosoever was speaking.
Yes, 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 sir.
Yes. After that, you see, then there are these blue brackets. Inside these blue brackets, every time there are two things. Yeah. So every time it will remain two, and within this yellow brackets, there are always three things. So what will be my new torch size? It will be 2 comma 2 comma 3. Any doubts in that?
Because you are adding one new element, that's why it's looking to the three.
Yes. Now I'll show this.
Yes, sir, clear.
See, 7 8 9 0 1 2 1 2 3 4 5 6. Now there are two at the first position. That is the outermost dimension. Inside that you have two, and inside that you have three. Let's say I remove this. it will not work because you have to maintain this. Because in the inner dimension I have to have a three thing always inside this yellow brackets, so I cannot play with this now. Okay, because see this seems very important also. If you see why it is an important thing, that if you start changing things in between, how will you maintain consistency when you have to train model on a very huge data set? We start changing things in between, then this dimension problem will be there. And this is second most common error in python that we can do. One thing is I told you some time back about the data type. Second is the dimension thing. You have to make sure the dimensions are correct across the structure you are saying. Okay, there are two raised hands.
So
Yes, yeah.
yeah, just want to ask, like, I found some shortcut trick if it's really working or not. Like, if I have to find n dimension, then I will see pink, blue, yellow bracket. Okay. So now after yellow there is no bracket. So I will come to the conclusion that there is three dimension: pink, blue, and yellow. Is that a correct way?
Uh, you can use, see, I won't say it is wrong, but this is your personal choice how you want to remember it. Yeah.
Because till now it's
Yes,
like,
Okay.
sir, I didn't get the size. I got the three, how you are saying three.
Hmm.
2 comma 2, I didn't still, I'm not getting.
Okay. Okay. Um, Let me try
I
again.
can explain if you want.
Yeah, please try. Okay.
Yeah. So you can see the pink bracket, right? The for outermost.
Yes.
So you don't have to consider that. So inside, so that's a main frame, right? So inside that you have blue brackets two times. The first one is this one, and the second one is like 1, 2, 3, and 4, 5, 6. Second one, right? So here comes 2, and the second 2 comes 7, 8, 9, 0, 1, 2, like this. And
Okay.
3 is column 7, 8, and 9. This is 3.
Did you understand? You can
Okay.
try
So we are
again,
not,
Shivani.
sir, we are not considering the outer bracket, pink bracket,
No, no,
No,
we
no.
are considering. We are considering. See, see, see.
No, no, just
for
think of it
dimension, sir.
like you've got three numbers, right? Two, two, and three.
Yeah, three numbers I got
Okay,
it.
if you
7, 8,
want
9.
to define the shape of a matrix, you do m cross n,
Yeah.
right? And the first number, just think of it as the number of matrices that you can make out of this. Okay, so if you've got two lists, that means you've got one matrix. Like the yellow brackets, consider those as rows of the matrix. When it comes out to be as a tensor, you can see the rows are positioned on top of each other, like you write down a matrix, right? So it's 7, 8, 9, 0, 1, 2. There are two separate rows of the matrix. Now, what this shape, it just think of it like you've got two 2 by 3 matrices. So it's 2, 2, and 3, just like that.
Okay. Yeah.
Then did you understand?
Yes. Yes, sir.
Little bit also, if you have understand, that's good to go because you will learn more
Yes.
about this along the time. Okay.
Okay.
Sir, excuse me. So the number of channels is the number of brackets here.
No. See, forget channels. Forget channels. There are three dimensions, right? X, Y, and Z now. Maybe you can think of that way. But yeah, brackets, with help of brackets, you can say that there are three dimensions. One is the pink bracket, one is the blue bracket, one is the this yellow bracket. And with the help of commas, where these commas are situated, and along with these brackets, you can identify which type it should be. Okay.
Oh, okay, sir. Thank you.
Yeah. Okay. Now, next thing is we have to see. Huh, okay. Mm, we have to learn how to create matrix of zeros, matrix of ones, and any random values matrix. Okay, this we are going to learn next. um, yeah, so now you know how to define these things, matrices and all those things. Okay, now I'll say 0, is a matrix name. Okay, I'll say torch dot zeros, and I want to see a 3 comma 4. So I have defined this. This will be a matrix only. And I'll say print 0. Let's see. So you get entire a tensor object of these zeros. So this is, if you see, this is the outer bracket, means there are, this is two dimensional. Why? Because there are only two brackets, and with the help you can with little bit see, you can see how many this will be there. Okay, now we see we have printed zeros. Let's try to see what is the shape of this 0 dot shape. 0 dot shape is 3 comma 4. Okay, then we can see what is the d type of this. What is the zeros dot d type? Zeros 0 d type. All of them are float 32. Okay, next we have on which device. Now device will start mattering to you guys. So we have two kind of devices here in collab. One is the CPU, one is the GPU. Mostly right now I'm using CPU. At the end of this class I will show you how to use GPU in Google Colab. And so 0 dot device, if I call, this means my currently I'm using a CPU, so that's why it is showing that. Again you can say 0 dot numel. Yeah, how many number of zeros are there, or maybe it's not good to say how many number of zeros. You can say how many number of items are present, elements are present, how many number of elements are present in my matrix. That is 12. Okay, okay. Next is, if I want to know what is the memory usage. Okay, so float 32, if you know, it requires 4 bytes. Am I correct? Any doubts in that? So what I will do, I'll just say 0 dot element underscore size. Okay, and I'll multiply this with 0 dot numel. What numel was giving me? Numel was giving me how many elements are present and what each element will accept, that is 4 bytes. So it should be 48 bytes. So this is in bytes. Okay, 48 bytes. Okay, okay, this is done.
So what is the numerics? Can you get this? So what is the numeric?
Numel is, I'll just write it down for you. It gives me the number of, it returns the total number of elements present in the present in the tensor, in the current tensor object. Yeah, this is fine. And then
So how you get 48?
yeah, I'll explain. This is in bytes. Why? Because the float 32 object requires 4 bytes now in memory. So for each
Yeah,
element
yeah.
I am taking 4 bytes. There are 12 elements, so it requires 48 elements. Oh, 48 bytes. Sorry. Got it? Okay. Now you can perform some things like you want to take the sum of all the elements, then you know what to do. Right?
Sir, I
Torch
didn't
dot.
get the concept behind the number of bytes. Can you please explain that once again?
Number of.
Sir, in the eighth line, you're
Okay.
calculating it in the number of bytes, right?
1 minute. 1 minute. Just let me write this sentence. Dot item. Yeah. I am saying. See, 0 dot numel, what it was giving me? It was giving me the total number of elements present in the current tensor object, right? Now,
Yes, sir.
float 32, even if you don't know, I'm telling you, every float 32 bit thing requires a 4 bytes of memory. This is universal.
Yes, sir.
You would have studied in some 12th class if you have taken computer science, or somewhere else also, or
Sir, in bad one. Yes, sir.
yeah, somewhere you have studied, na? So what I'm doing, just I'm multiplying. So see, one element requires 4 bytes. Then what does 12
Okay,
elements
okay,
require?
sir, I got it.
48
Got it.
bytes.
Got it.
That's all. Okay. Now if you do sum of zeros, that will be 0 only. If I want to take the you, so mean you have already seen, norm you have already seen. This time I'll show you standard deviation. Okay, print
So line number 10 is printing what?
sum of all the tensor objects that are present.
So why is it not showing 0?
No, I have not pressed enter after that. That's why.
Oh, okay, sorry. Okay.
Dot item. So you guys have already seen how to bring mean. You have seen norm. Now you will see standard deviation. Okay. The standard deviation is also 0 for this. Not much different. Yeah.
Yeah,
So
delta 0.
okay. So yeah, this is done. This is done. Now let's try to this we have done. Now let's try to where zeros will be used, let me just give you small application. So what happens in LLM during the mass language modeling in the BERT architecture? Okay, so you will study this in LLM course and might be in this course as well. We use a masking matrix, and that masking matrix has half of the elements is zeros and other half is minus infinity. It has some concepts why it is minus infinity. In such places, things like that, like things like those places, you have to create your own zeros matrix, and how that zeros matrix will get slowly get reevaluated. In those kind of concepts you will get to use zero matrix. Then similarly for ones matrix also. Okay, so we'll see what ones matrix is there. So this is the major application where you guys there will be different kind of things where you can use this zeros matrix and ones matrix. Okay. Okay. um yeah, now let's call a new matrix one torch dot ones, and I'll say 3.4 print 1. So I got this. I'll take entire thing because this you guys have already seen. Shape you have seen, data type you have seen. What will be data type? Again, float 32. What is the device? CPU. Numeral is the total number of elements that is present in the current tensor object. That will be again 12. And what is the element size? Now you guys know that since each float object requires 4 bytes, you will multiply it with the number of elements that you get by numeral, 1.numeral, and with that you will get 48 bytes. Okay.
So by
Yeah.
default, they have float.
What if?
Uh, yeah, torch dot ones or torch dot zeros are by default for
Yes,
float
yes,
30.
yes.
Cannot be integer.
Let me try that for you. I think so. There is something you have to just let me see. How you can do this. See, type is there, size is there, D type is there, na? Yeah. Then let me try.
Oh,
Okay, let me try.
so we can set the D type as 96.
Uh, just a minute. D type is now I don't remember.
Okay, no worries. So we will see. I
Okay,
got
sir,
it, sir.
sir.
Mm, yeah, see, you can define it as int 64 also. That is not a problem. If you want, I'll
Okay.
see it right now. Otherwise, you can try it on your own.
You can try, sir.
Oh, I should
If
try.
it's,
Okay, then let me see.
yeah.
Confirm this one. So, search. Type. Okay, yeah. It will be torch dot int 64. Yeah, now it works. Okay,
Nice.
but before moving ahead, now you tell me why this is 96.
Sir, because the
For
number of bytes is changing because the
Very good.
bits went up from 48 to 64.
Very good.
4
So
bytes.
int 64 requires, I think so, 8 bytes of memory.
8 bytes, sir.
8 is 64.
Yes, sir, it
8
is
by
a
8 into
64.
12
Uh,
equals to 96.
96.
It requires 8 bytes. That's right. So you can change the data type also, but be very careful with your data type. It will create a huge havoc. Okay.
Yeah.
So,
So
sir, what
six.
is the purpose of printing the device in line number first?
Just to have fun, maybe. And other thing
I
is
mean,
that in this TA session, I will try to cover the difference between CPU and GPU in Google.
oh, okay.
Just I'm familiarizing you with the functions that you should know which to call, because there is one more mistake, common mistake. if your tensor is stored in one tensor is stored in GPU and one tensor is stored in CPU memory, you can't perform any operation between them. No operation will work.
Okay, so device type, if it is
Yeah.
different for both tensor, it won't work. I mean,
Sorry, sir.
uh,
Can you repeat again?
if the device type is different for
Yes.
the both tensors, then between them there can be no
No
operations performed.
operation. That's why
Both
just
tensor.
just to
So
familiarize you these things.
so it means if I have multiple graphic card of different companies, then there is no use of like I cannot combine their power.
So you can combine their power, but I would suggest not right now. We
Okay,
have
sir.
only like maximum I have tried is NVIDIA SMI A100 GPU, and
Mm.
there are two cores in that, so you can do parallel things. But I would still
Oh,
say there are some problems there. It is not very easy.
yeah, and it's very expensive by the way for our course.
Yeah,
Like if
that is
we
not
want
mine
to find,
also. That is given by the lab to work on. So yes.
yeah,
So if you have so many GPUs, then I don't think so. You need to study DS engineering. You can have
yes, sir.
fun with those GPUs only. Okay. Um.
Sir, one more thing,
Yeah.
I've not understood why we are using GPU. Means why do we need the GPU power? Why do we need the GPU power?
Okay. So the biggest thing that the GPU provides you is the computation power. Now, right now you will see we will do some matrix multiplication. Okay. I don't know whether today we'll be able to do it or not, but yeah, we have to do matrix multiplication. When you are doing a simple matrix multiplication of 3 comma 2 multiplied by 2 comma 3, then you know you will get your answer 3 cross 3, right? But when you are doing for an embedding is in terms of 1 million, and you have to multiply a 1 million matrix into a 1 million transpose matrix. How will you do it then? You can't rely on CPU for that. That's why GPU, that's the place where GPU comes in. It can do those computations very, very fast in a
So
very
extensive calculation GPU can perform much faster than
yes,
CPU.
yes. The biggest thing is, as Sarah has also mentioned, and we'll see in the lectures, this matrix multiplication is a very complicated thing. When you are doing this NLP task, like you have to store these embeddings, and you have a vocabulary of 42,000. What is the standard vocabulary? And then you try to form those embedding dimension matrix. Then you have to multiply. At one place, you have to do W transpose something, so you have to multiply 1 million into 1 million. That is almost 10 raised to power 6 plus 6, 10 raised to power 12. So you have to wait a long time for that. But GPU can do that very fast for you. So that is the place where it will be. Okay.
Sir, if you have like very good knowledge of operating system and computer architecture, so we can like very make it very efficient, like make it way faster with that
Yeah,
knowledge.
yeah, you can do it.
Okay, sir.
So how operating system?
No, no, operating system is just saying because let's say you have a graphic card for a GPU, then you don't have to rely on Google Colab. If you are you can buy those things, then you can try it on your own computer. Okay, should I move ahead?
So, so like the one you have told, the use of GPU is because the computational power, uh, like the architecture of the GPU, like you have recently told that in the above time, like in LM in the but architecture, like how we define those architecture. Like I also know that ChatGPT works on some architecture. Like how do we build those architecture?
Yeah, that's what this course is about. Now you will learn how to build architecture for ChatGPT and BERT.
But, so I want to ask that in this course we will learn about how to learn the architecture, right?
No, not exactly this course, but yeah, in this degree you will learn.
So,
So
so how it is different from the models? Because in MLP we have been taught about only the basic models only. They are
yeah,
told
so
that they will
models
the
can be of
basic
many
architecture.
kinds, right? So regression, you saw there are some models for regression, for classification. Then you will learn about neural networks, how deep neural networks can be, with so many hidden layers can be found. Then you will study some architectures for these like the early models that came like GPT-1, BERT. These things you will learn across this course, and then you will slowly learn how to develop those architectures yourself. Fine, should I move it?
Yes, yes.
Okay. Okay, you have seen the matrix for ones, you have seen the matrix for um, zeros. Now let's build a random matrix. With that, I'll introduce one more concept known as random seed. Some of you would have seen random seed and you would be knowing what this random seed does, but nevertheless, I'll cover this. Okay. Okay. So this is a random tensor. I'll call it random itself. And torch dot is ran 3 comma 4. So, I'll just say 3 comma 4, and let's see, print random. Okay, so these are some values. I get another values. I get again another values. Now I'm not showing you other things because you have seen the usage of this shape, d type, device, numeral, and all those things. I'm moving ahead directly now. So now there is one.
Sir, what is tensor?
What is
Tensor.
did you join just now? Because for
Yes, sir.
past 1.5 hours we have been talking about tensors only. Okay, so it is an object that is used in PyTorch to define a particular. It is a data structure for a deep learning language. You can think of like that. And we'll be
Okay, sir.
using tensors across the this course for all types of computations. Okay. Okay.
So can we say that tensor is a complex or sophisticated name for matrix or something?
No, because matrix, vectors, scalars, and three dimensions. Everything is being handled by tensors now. So you cannot say only it is a matrix because matrix means it is a two-dimensional structure.
No, sir, I'm just being mathematical or something. Not,
No, no,
not
still they are much different. Better
okay, sir.
not to, better not to like mix them.
So tensor
Okay,
is
okay,
far
sir.
more generalized than scalars,
Yes,
vectors, or
yes,
matrices.
that is for sure. Yes.
Like it can encompass all three if it wants to. 1D also, 2D also, 3D also. Matrices and vectors and scalars are far more specific.
It can encompasses everything: scalars, vectors, matrices, and three dimensional structures, whatever they are called.
Like it's a superset of everything.
Superset of it.
Yeah, yes.
Okay. Now, if you see one problem, this random matrix is changing every time I press enter, right? This is not good. Why this is not good? Now, let's say I'll take you guys example only. Let's say you write in your paper, you have some question in which you have to you have to bring a random. Let's say you have to create a random matrix, and on that random matrix you have to multiply 10 on it, and then you will get certain answer, something, let's say x. Now, if you call this torch.rand, what will happen? Every time you run this, everyone will have different results. And not even that, the day you wrote the exam will be different, and when the somebody is checking your notebook, it will be different. So that is a huge problem, right? So for that, to maintain a reproducibility, this term is called reproducibility, means whatever you have written, it should be same when somebody else is running your notebook. For that purpose, we use a concept known as random seed. Okay, so what I'll do, I'll keep this cell here itself. In a new cell, I'll introduce a new thing called random score seed. And for, let's say, you can, I'm saying this 42, you can specify this anything. And I'll say torch, and I'm manually feeding this to torch. So torch dot manual underscore seed, and I pass this random seed. Okay. Now when I do this torch dot run, I'll get some values. You just focus on the first value, 0.8823. Okay. Now every time I get the same value. May even I run this cell 1,000 times, this will not change. Why? Because I have fixed it that there is some specific, let's say specific. This is a, you can say, you can think of this in a very vague way, that this is a nutshell. Now this is a small environment of random seed 42. In that you have kept a particular torch.rand matrix, and now that matrix will have a fixed value. It will not change. Is it clear, everyone? What we did here?
So, sir, basically, if you try to change the random seed value, then the matrix will change,
Yes.
value will change,
Otherwise, it will
right?
not change. See, now I changed it to 41. Your value changed to
Mm.
0.2364. Now
Okay,
0.2364 will always remain same.
So can you
okay.
change it for 42 again?
Yeah, yeah.
42. Okay. And if we run the same program, exact same program to some other PC or some other collab, the value will be changed, right?
No.
Yeah.
Kind of thing. So then it will always remain same. Otherwise, it will
Yeah. Yeah. So like we are getting 0.8823 as a first value, right? Every time we with random seed equals to 42. Now let's suppose I am running the exact program in my PC.
I'm running now. I'm getting the same thing.
Same. It will be same in
Okay.
all PCs.
Yes, sir.
It won't
Okay.
change.
it will change.
Okay.
It will
Thank.
remain same in every computer.
Okay.
Okay. This
Sir,
much is
sir,
clear.
so if we don't set the random seed, whenever we press the random, the random seed will be assigned randomly anytime.
Yes, 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 yes.
Okay,
By
okay,
default, it takes some any value it can take.
okay. If we assign it, it will be constant, the random seed. Otherwise, the random seed will be random.
Hmm, hmm.
Okay, fine. Got it.
Okay. Should I move ahead now?
Sir, you told something about its purpose in the initial when you were explaining this. Can you repeat that, sir?
Reproducibility. That term is called reproducibility. Yeah.
Okay, reproducibility.
Okay.
Okay.
So if we run like this way, then it will no more be random because I already know that with 3 comma 4 shape, I'll always get the same value in any PC.
Now, still, these are very randomized values. You can't say this. How will you know what where to put 0.9593? It is still randomized only. And
So
then
because we are
second,
getting
see. Will you remember for 1,000 random seeds what are the values? No, no.
no, sir, definitely. Yeah.
That's why it is randomized. It is still
Okay, sir,
random.
thank you.
Only thing is that I want to fix those numbers because I don't want my experiment to have different loss functions every time somebody else runs. So this
Okay, sir.
we have to ensure this. So just for that insurity, I'm using a random seed. That is the only concept.
Okay.
But sir, is this not called as pseudo random?
No. Please don't introduce new terms. There is
No, sir, it's not a new term in mathematics because pseudo random. When we talk about pseudo random, is something because we are setting the initial seed, right? So every time we set the seed, so we will still get these numbers, but it's still at initial stage these are random, and that's why in maths we have pseudo random concept, which is exactly the same thing. Yes.
it might be there. I don't know about that, so I won't comment anything on it. Okay. Okay, now moving to some basic operations like addition, subtraction, element-wise multiplication, and matrix multiplication in how to do that using tensors. Okay, so let's define some new variable var is equal to torch.tensor, and I have introduced a list 1 comma 2 comma 3, and I want to do var plus 10. What will happen? This 10 will get added to every element. So it became 10, 11, 12, and 13. What if I want minus? Then I'll get minus 9, minus 8, minus 7. What if I do
So why it is showing a yellow line, curly line?
it is
Is
unused.
there
That's
any error?
that's the only thing. Expression value
Oh,
is
okay,
unused. This is a warning.
okay.
Nothing to worry
Ach,
about. Report unused expression. That's all. If I do multiplication, it will multiply. Okay. Now we try to do something else. Okay. Now we have where is there already. So what I'll do, print where multiplied by where. Okay. This is 1, 4, and 9. I'll explain you why this is happening, and I'll also write it down here. That this star in tensors means that we are doing an element wise multiplication. Multiplication.
so is it not dot product?
No, this is no dot product means you add also, no? I'm not adding anything. I'm just
Okay.
multiplying.
Oh,
At the rate.
okay.
Yeah, this will that will come later. Okay, so what I am doing is 1, comma 2, comma 3, and I multiply this 1, comma 2, comma 3. So what will happen? I am multiplying 1 into 1, comma 2, comma into 2, comma 3
Mm,
into 3. Okay, and again this is a list. Okay, so means again that this is tensor list. So yeah. So 1 comma 1, 2 comma 2, and 3 comma 3, but they are separated by commas, not by addition. Okay, that is not a dot.
okay,
This is not a dot product. This is element wise multiplication.
okay.
Okay. Now if you solve this, this will come 1 comma 4 comma 9. Okay, this will not work.
Yeah. But instead of this, we could have done where power to
We could have done. Yeah, that is.
where
I'm just
star
showing you
started.
how
Oh,
element wise multiplication is done.
okay,
This is
okay.
showing you we can do this one. Okay, is this much part clear? Three operations we have seen: a simple element wise multiplication, simple addition, simple subtraction. We have seen this much. This much clear to everyone?
Sir, in tensors also is it called broadcasting? This like in NumPy we call it broadcasting, right? That it converts basically it converts the 10 to internally to a vector of 10 comma 10 comma 10. So in NumPy we call it broadcasting. In tensors is it also called the same, or do we have another term for it?
I don't know about this. Maybe I'll check and I'll get back to you. Maybe in the next session. I don't know
Oh,
about this.
okay.
Okay. Uh, okay. Now we move to matrix multiplication. Okay. So how matrix multiplication is done? First thing is we can use it is given by a function called matmul. You can also say and you can use at the rate also. So there are three options to do a matrix multiplication. Now we are using the same torch sensor. Okay. Now what can you tell me about this 1 comma 2 comma 3? What is this? This is 1 cross 3 matrix, right?
Yes.
Yes. Now if you do a transpose, what will happen? It will be a 3 cross 1 matrix, right?
Yeah.
Yes, very good. Now I can do matrix multiplication because 3 3 is common.
Mm, yes.
Yes.
Yeah, yeah.
But now my answer will be 1 cross 1. That will be a single value.
Yeah. Scalar value.
Yes, it will be a scalar value. Very good. So 1 comma 2 comma 3 multiplied by 1 comma 2 comma 3 transpose. What will be the result? 1 into 1 plus 2 into 2 plus 3 into 3. That is 1 plus 4
Okay.
plus 9. That is 14. Am I correct?
Yes.
Yes, sir. Yes, sir. Yes, sir.
This much part is clear to everyone now.
Yes. Yes.
Very good. So now I'll say print var.
So, sir, I'm sorry to interrupt. I wanted to check, are you going to record these sessions
This
going
session is
further?
getting recorded. I'm
Okay,
doing
is
it
it
locally
recording
on my
or
PC. and I'll give you
Mhm.
both this IPYHB notebook what I have done today and this recording also. Okay, this will be shared to you
Okay.
guys. Okay, yeah. So var dot shape. Now I want to do matrix multiplication. So matrix result is stored in this. So torch dot matmul. So matmul is mat multiplication. Var comma var. Now you see you don't have to specify the transpose. It can do it itself. Okay. So and I'll show this print matrix result and print matrix underscore result dot shape. Yeah. So 1 comma 2 comma 3. The size was 3, right? Because three elements were present, but it is still one dimensional. And when I did the matrix multiplication, I got the result in a scalar value, which is a zero dimension thing. That's why this is empty, and this is 40.
So
Is that fine?
shape of this is empty. Torch dot size.
No, this is not empty. It is zero dimensions. That's all you can say. So it does not have any
Okay.
shape.
Okay.
Fine.
So does not have any dimensions means sorry, like
If we are not
no, if it is scalar it is no shape.
No shape,
Yeah, single
zero
value.
dimension. Yeah.
no
Dimension.
See, no
dimension.
single value. You can't have any shape now.
Yes sir, yes sir.
Hmm. So, sir, MATML is trying to convert this var transpose into transpose and doing the
Yeah, it
multiplication.
does it on its own. I'll show you another example where I do var.
Sir,
1 minute, 1 minute.
yeah.
Var into var. So this is the at is the standard notation for matrix multiplication. If you do this, you'll get the 1 minute. Just 1 minute. I'll take your doubts. Just let me complete this. Torch dot var comma var. Self must be a matrix. Okay, module. Why is not working? Okay, leave this. Okay, leave this for now. These are the two things you'll see. I think so. Why is not working? I don't know. I'll check this later. Yeah, now you guys were asking something.
Yeah, that was vector, I guess. No, 1, 2, 3 is vector, not matrix, I guess.
Ah, yes, correct. So that's why it is not working. So it should be a multiplication of matrices in but these things allow other. Yeah, you are correct. Yes. This is a vector, and you have to give in a both sides should be a matrix. And there is some problem with MMT. Yeah. Okay, no worries. Yeah, this much is fine. Somebody was asking something. Please ask. Any doubts till this place?
So for the matrix multiplication, we don't need to write dot transpose,
No,
right?
no.
Okay.
But you will learn. You will learn about transpose also. I think so. If time allows today or otherwise some other day, transpose is there and we will use it somewhere. Okay.
Okay.
So, some MATML is basically trying to do a dot product of two vectors, but one with a transpose, right? Where comma where.
Can you repeat? Sorry. Can you repeat once? Sorry.
I'm saying, sir, MATML is trying to do a dot product of where comma where, but it is taking the matrix as a transpose.
Yeah. One matrix has to be a transpose, otherwise it won't happen.
Much. Okay. So that is it is doing by itself.
Yes.
MATML.
Yes.
I mean converting.
Yes.
Okay.
So here you have taken the same matrix, right? Where and where. If suppose I am taking a different matrix like A and B, if the A is of size 3 comma 2 and 3 plus 2 and B is also I am giving it as 3 plus 2, it will transpose it.
It should. It should. We have to check that. See, the general practice is we should give ourselves like if you want to do a matrix multiplication, we should better we our dimensions be correct. If we are multiplying a 3 cross 2 with 3 cross 2, originally this is not possible, right? You can only multiply a 3 cross 2 into a 2 cross 3 matrix. Then you will get a 3 cross 3 matrix. Am I correct?
Yes.
Yes. So
So it has to do a transpose.
it will do a
If
transpose
you
most probably, but we will see different ways where you can write on your own that please take a transpose only, please don't think too much on your own, something like that. We'll see where it will happen. Is it fine?
okay.
Sir,
Okay.
if we store some, let's say, some image to a tensor, so can it understand its own, the dimension of the image?
uh, uh, um, if what you are saying, I upload an image and you should give me the
Yes, sir.
dimensions.
So I want to
That
understand
dimension
whether
is given
tensor
by
can.
general operating system only. It tells you how many pixels into how many pixels were there, isn't it? Like, but if you give it to a tensor object, then it will think of it as a one comma pixels into width or whatever that thing is, height into width.
Does
Because
that mean it understand or doesn't it
it
doesn't?
means that it has only one channel.
So when you say channel, what do you mean by channel?
Yeah, that's why I was not talking about this.
Okay,
It
but
is,
that's fine, sir. If
yeah,
we
yeah.
are going to cover in the later
Yeah,
session,
it
so
is
that's
week
fine.
10, 11, and 12 computer vision. Okay,
Oh my
you will
god.
study there.
Today is just the introduction session. I mean,
Yes.
why are we discussing week 10 level?
Okay. Um, okay, good. Okay. Now for a change, I hope you guys have understood few things. I'll get back to it. There are few more important things like squeeze, unsqueeze, and those functions are there. Before that, I'll show you little bit fun things like CUDA availability. So let's try that now. Okay. So what I'll do, if you guys see here, you can also do this. You can connect, you can change the runtime type, okay? And here you will see these GPUs, okay? Since this is the ITM student account, you will have this T4, like, it should be like in normal also you should have this. So this is T4 GPU is given to me and I have Python 3. It will take the latest version. And if I save this, now you see my it will show connecting to T4. T4 GPU is available to me. So I'm connecting to it. Now, till the time it gets connected, I'll write the code for this. So import torch is always there. So I'll say CUDA avail, okay, is equal to torch dot CUDA dot is underscore available. Okay, is available is a function. Okay, now since we haven't still connected, so it will say false right now. I think so.
So is this
Can we
CUDA?
take
Hello.
Sorry.
What is
Did
this CUDA?
CUDA is NVIDIA GPU in general term.
NVIDIA GPU.
NVIDIA GPU is in whenever we code it now, it will we have to write CUDA only. I don't know for what reason, but it is called CUDA.
so can we take TPU?
PPU means
Instead of GPU, we can take TPU. Then there
no.
was option, huh?
So
No.
TPU, I'll tell you, there is an option, but I just tell you, TPU is for other purposes. There are some specific purposes where TPU will help you. But for our purpose, let's use GPU for now.
Okay, sir.
TPU has its own good things, and but remember, if you use Kaggle now, so Kaggle will give you 30 hours of GPU, but only 20 hours of TPU. So you have to use
Oh,
for every week, and it gets. The last time I was working on Kaggle, it used to um, it used to reset on Sunday morning 5:30 a.m. every
okay.
week. Okay, so
Yeah,
yeah, so you please check those things. Okay, for us
yeah,
we
I
are
know
using
it's. Yeah.
okay, yeah. So now, acha, you saw that there was a mistake. It said why torch is not there. Now, remember from the 9:30 time whatever we have been working on this PyTorch, what we were doing, we were writing all this code on CPU. So my GPU doesn't know that we have a torch module, right? So we have to explain it to GPU also by writing import torch, and my entire runtime has got lost now because I changed my runtime. That is another reason why, if you are working on GPU, please work on GPU only. If you are working on CPU, please work on CPU. Otherwise, please mention in your code, like I will do right now, that if GPU is available, do this. If CPU is available, then do this. If both of them are available, then do this. You have to specify this. This is a very important thing, specifically from an application point of view. Okay, is it clear, everyone? Precautionary
Could you
thing.
please repeat?
Okay, I'll repeat again.
Sorry, sir.
This is
Okay,
important because
yeah. So, sorry, what did you say?
sir, could you please repeat that? This is
Uh,
important because
okay, this is important. Okay, I forgot. Huh. So I was telling then, they see right now what happened in this earlier. I was not importing torch every time I wrote a new code, but in this place, since I changed my runtime, I had to import torch because my GPU doesn't know I have imported torch already, but my CPU knew that I have imported torch, so it was able to handle everything. This is another reason why you should explicitly mention in your code, which I will show you one example right now. If CPU is available, then do this. If GPU is available, then do this. If both are available, then you have to segregate the work. Do some tasks will go to CPU, some tasks will go to GPU. You can do this. You can achieve this thing. But you have to be very careful that there should not be any interdependency between them. If there is any interdependency, then there is a problem. Okay,
so
guys.
basically we are
Basically,
saying
we
when
want
you are okay, sorry, please continue.
Yeah, yeah. You are asking. Please ask. It's okay.
Yes, okay. I was saying if you are running things if you're running your code on CPU
Ah,
and meanwhile you switch to GPU, then existing memory basically it will lose.
runtime will use.
Is that what
Yeah,
it?
yeah. Runtime will get lost.
Yes, runtime at runtime. Yes. Okay. So
basically
we
we
will
are
make
sharing
sure
the
that
resources.
Hanji, yes.
Yeah, so that's why for bigger tasks we will use GPU, and if there is no interdependency, then we'll use GPU. If there's interdependency, we have to take care of these things. And the small tasks we can proceed with CPU because CPU has more resources. So wasting GPU doesn't make any sense.
Hmm. Good. Yeah. So this much is clear. Should I tell you what are other things? Can't we do everything in GPU? You can,
Hanji, Hanji.
but
Please
one day
continue.
you will
Yes.
realize that still your GPU is less. That is the beauty. Okay. Okay.
So there is
So,
more powerful than GPU. I mean, uh, more powerful
So like the architecture of like on
architecture.
what GPU the chat GPT works. Tesla's big one.
like in general, like right now, I think so 80 GB A100 GPUs are the best in the market. Okay. Right now in our like labs, like what I use is 12 GB. Now in 12 GB, you can't even run Llama 3.3 locally. 70 billion model you can't run. It requires 20 GB of GPU access in one go. So, so you will think that wow, 12 GB is too much on a local computer, but it is nothing. You have to see some other things. There are some workarounds for that. Okay, so you'll learn about those things soon.
Sir, can you please repeat
Now, this
my
thing
time?
has not to be repeated. This is just a personal experience I was sharing. Okay?
Okay.
So, CUDA will, this CUDA will, it is a true false. It is a Boolean variable. Okay. Now, what I'll do, if CUDA will is true, okay, then I'll say print. Let's print and see what are the different kinds of things. First, let us see what is this device name. Okay, what is the device of this name of this CUDA? So torch.CUDA dot get underscore device underscore name zeroth element. Okay, I think so. Okay, this is not
So
a
you have
square bracket.
always,
Yeah,
so it
yeah.
should be queued away. You have written queued away.
What?
The variable name is queued away. You are
No,
always
see,
saying queued
variable can be
away.
anything. Yeah, I made a
Okay,
mistake, but a variable can be anything. This should be correct.
that's all.
Your function should be correct. This is my
Function
personal
is queued
variable.
away.
You can make it cute also. That does not make sense. It's fine. It's okay. Okay. Function name is CUDA. CUDA. Okay.
CUDA. Okay.
Print. We got the name. We'll see what is the name. Then we'll see torch.CUDA dot how many devices I have. Okay. That will give me the device count. Then I can see print torch dot CUDA dot current underscore device. Okay, we have to see this. Now we'll also see what is the memory that is present with us. So also print torch dot CUDA dot memory allocated again zero have to be put. Print torch dot CUDA dot memory reserved. There is some reserved also.
Sir, all these are the functions associated with CUDA. I mean,
Yeah, it is
um,
specific to CUDA. It is specific to CUDA. Yes. You see,
okay.
because it's you see all my this you can see with the help of these dots also. No? From torch I call CUDA. From CUDA I call memory reserve. It goes on like this. You have to read it like this.
Memory what?
What? Sorry, memory reserve.
Uh,
I'll show you what.
reserve. Okay.
Okay. Why it is zero?
Sir, can you remove zero? That would be like I've also used that without zero.
It is working. No, no, no. Then we made
No
one
work.
mistake. One minute. One minute. Print torch dot CUDA dot get underscore device underscore properties. Then I call zero dot total memory underscore memory. Yeah, now it came. Yes. Okay. So what is the first thing? You see the get device name is T4 GPU. How many count? How many devices? That is the cores. So you would be if somebody is
So Tesla T4, right?
what?
Device name.
Sorry.
Tesla T4 is a device name, right?
Yes, yes. Tesla T4 is the name of my GPU. That is available for everyone. That is available for everyone. And CUDA.device count, how many cores I have. So I have only one core. Current device, is this is the current device. This is true. I'm using it in the current device. And get device properties total memory. Now what you see this is in bytes. Okay. Now if you convert it, you will get the exact value that was written here. If you see, I think so. Everyone gets. It's not written here. Somewhere it is written that this is 14 GB. Okay. So if you convert this, you will get the answer 14 GB.
Okay.
Okay. This is fine,
This is
everyone.
in bytes, right?
Yes. Bytes are.
Sir, we have
Okay.
something.
Hmm.
Okay.
No, tell.
Yeah, directly if you use get device properties instead of total memory, we remove total memory. Then it will give even more info, right? Device property 0. That's it.
Okay. You are saying this. No?
Yeah. Now.
Ah, see, Tesla T4 major 7 minor 5 total memory 15 MB means 15 GB, right? 15,000 MB means 15 GB. Multiprocessor count is 40, UUID is this, and your L2 cache size is 4 MB. Some PCI device ID is also given, domain ID, pass ID. Yeah, these things are available. You can study this. Okay, is this part clear, everyone? Guys, yeah, Lee,
Yes, yes.
please tell.
No, sir, it was by accident. Sorry.
Okay. It's Muhammad Arshad Ali.
Sir, in my case, this is CUDA is available is showing false. Why?
You have to change the runtime, no? Runtime type. You have to show this. Change runtime type. Then you have to select
Mhm.
T4 GPU. Then only it will work. Otherwise, it won't work.
T for GPU. Okay, sir.
Okay.
Thank you.
Uh, okay. Everyone clear on this one, right? Now I'll show you one last thing. What if your GPU was not available? What it will show? Okay. I've deleted the runtime of GPU. I won't come back again on this now. So else print GPU not available. I also don't know what is major counter. Chandrasekhar. Okay, GPU is now not available because I've changed the runtime to CPU. Okay, actually you can the function allows you to specify in strings that whether you want to use. So it never use GPU in string. You have to use either a CPU or you have to use a CUDA. Okay, these are the two things. Okay.
Can we use a question mark here, like we used to do in sklearn? Question mark, and then get to find this thing.
Question mark.
Like in sklearn, we used to write some model name and then question mark, so that model name, all parameters it used to show, like what
All
this is doing.
documentation.
No. That is specific to
Help.
sklearn, I think so. It won't work here. But you see, if you see very carefully, it gives you. If I remove this, I write dot. If I wait here, I think so. Yeah, see, device count, device memory used, it
So,
will give you.
so
So
we
you
can
need to
we can
press
also get via
and
directory, right? Print directory torch.cuda like this. dir torch.cuda.
Print
dir
dir.
bracket torch.cuda. Yeah, this one. And okay,
Oh, it is not working here.
it's not working. Okay.
Because I've removed the runtime now. It wastes
you
time.
have
That's why
changed
I'm
CPU.
going back again. If it works, great
Okay.
then. You can use that. Okay.
Yes.
Okay, I have told you these things. Now, three errors that are common. I'm writing it down. Three errors that are common. Please don't make them. Please don't make them. So we have discussed them also. So first is the the matrix sizes should be compatible with each other. Otherwise, you get a runtime error. Okay. Second is the data type problem. Um, yeah. So the matrix, no, the data types of the tensors should be compatible to each other. Should be same, not compatible. Should be same if you want to perform. If you want to perform any operations between them. Okay. And third is the if you are performing operations on two tensors which are present on two different devices like CPU or CUDA, like one is present on CPU and another one is present on CUDA, then again you will get a runtime error. Okay, these are some three common errors which at this initial stage you can make. So I have written them down. Please don't make them. Okay. Yeah. So this is done. Now I think so. Time is up. I wanted to cover this reshape, squeeze, and unsqueeze, but it will take another half an hour, so we can skip this for now. So, yeah. Any other doubts? Yeah. Big chill. Yeah. Please ask.
Sir, this TA session of today, like it collided with another Mat 2 course live session. So I couldn't watch this lecture. Will this schedule change in upcoming weeks?
I'm not sure. This is in not my hands. So you have to raise this in discourse. Instructors only can change the timings. But anyways, you have recording. You can watch the recording and you can ask your doubts on discourse and you can come in next session to ask the doubts.
Sir, so the recordings will be available as soon as this session ends on YouTube.
Not on YouTube since I have recorded it locally. So I will upload it to a drive folder somewhere and I'll also upload what I have written in this notebook today and that might be uploaded and then you
Sir,
can
in the calendar also you can attach the recording.
yeah but it is very big recording now. It's 2.5 hours recording. So
No, no, in the calendar for the meet link.
but meet link recording is not happening. I'm doing it locally today.
Yeah, yeah, I'm saying the recorded video only.
Oh, okay. So
If you
if
can
that can be
attach.
done, I can't. I don't have that those permissions. That will be done by the instructors only. It's not in my hands.
So, but last term MLP TA sessions were being recorded. The links were being added in the calendars.
Okay. So you raise those things in the discourse. Instructors will handle it.
Sir, can you please share the link via Discourse post?
Okay. So far we haven't like TAs haven't got their access to discourse. Once we get, we will let you know.
So like today you have completed with the topics, or you will take the doubts only, right?
Sorry, Shubham. Can you please repeat?
Like I'm asking that the teaching part of you is now complete. You are now just asking for doubts, right?
Yeah. If you have any doubts, you can ask. Yeah, so just a minute, I'll stop the recording.